Can we withstand what is coming even while everything may seem serene? When we glance up at the night sky, appearances can be deceiving. Our galaxy, the Milky Way, is speeding through the universe at an astounding 1.3 million miles per hour, even though we may not feel it. Additionally, it is heading straight for its neighbor, the Andromeda Galaxy. The distance between these spiral galaxies, 2.5 million light-years, won't matter soon. We are about to witness the biggest galaxy collision, as the Andromeda and Milky Way galaxies are on a collision course. How well equipped are we for what might be our demise? Will Jupiter once more protect us, or will it actually be a threat? In this video we're going to find out if we can survive the largest collision our galaxy has ever seen in history. The Milky Way is far smaller than the Andromeda Galaxy, which is speeding toward us at 68 miles per second. Even if that might seem quick, it will still take 4 billion years for these galaxies to collide because of their distance. Eventually, they will merge to form a single massive spherical galaxy, which will take roughly 6 billion years. The supermassive black holes at the centers of the Milky Way and Andromeda will also merge in this new galaxy, which is referred to as Milkomeda or Milkdromeda. Although the idea of such a massive collision sounds terrifying, scientists point out that individual stars are unlikely to collide due to the vast distances between them. Our solar system should also remain secure. There is a slight risk that it could be entirely ejected from Milkomeda, but researchers predict it will most likely be swept to the edge of the new galaxy. In either case, it's doubtful that humans will be alive to witness this breathtaking light display, as by this time the sun will have heated up to the point of destroying life as we know it on Earth. The Andromeda-Milky Way collision is fascinating because we have known about it for hundreds of years. Astronomer Vesto Slipher predicted that the Andromeda Galaxy would collide with the Milky Way in the early 1900s. Since then, numerous scientists have developed simulations to determine whether these galaxies will collide or simply avoid one another. Data from the telescope in 2012 confirmed there will undoubtedly be a collision. It is critical to keep in mind that these kinds of encounters are common and expected. In fact, a major collision involving the Milky Way occurred around 10 billion years ago, and smaller galaxies are frequently absorbed by larger galaxies as they pass through their orbits. It's amazing to look at the simulations and realize that we're utilizing science to forecast the future. Even though we might not be here to see the development of Milkomeda, the insights into these galactic events remain inspiring. The largest icy comet nucleus ever observed by astronomers has been measured by NASA's Hubble Space Telescope. It is larger than the state of Rhode Island, with an estimated diameter of about 80 miles. The nucleus is roughly 50 times bigger than the center of most observed comets and is thought to be 500 trillion times heavier than the average comet, with an astonishing mass of 500 trillion tons. On the other hand, Comet C/2014 UN-271, a massive comet, is hurtling toward Earth at a speed of 22,000 miles per hour. But don't be alarmed, it will never come closer to the Sun than 1 billion miles, slightly farther than Saturn's distance. This event won't happen until 2031. Comet C/202 VQ-94, whose nucleus is thought to be 60 miles across, previously held the record. Astronomers Pedro Bernardinelli and Gary Bernstein discovered Comet C/2014 UN-271 in old photographs from the Dark Energy Survey at the Cerro Tololo Inter-American Observatory in Chile. It was accidentally discovered in November 2010 when it was a staggering 3 billion miles from the Sun, close to Neptune's typical distance. Since then, extensive research using ground and space-based telescopes has been conducted on it. Comet C/2014 UN-271 was later given the more pronounceable name Comet Bernardinelli-Bernstein. Manta Hui of the Macau University of Science and Technology in Taipei, Macau, who is the lead author of the study, remarked on the comet's significance. He noted, "This is an astonishing object given how active it is when it's still so distant from the Sun." The team utilized Hubble to capture images of the comet in January 2022, tackling the challenge of separating the solid nucleus from the massive dusty coma surrounding it. The comet is now too far away from Hubble to resolve its nucleus visually. Instead, a bright spike of light near the nucleus in the Hubble data was analyzed. The surrounding coma's light was modeled and subtracted to reveal the star-like nucleus. The data from Hubble was compared to prior radio observations made in Chile using the Atacama Large Millimeter/Submillimeter Array, ALMA. These observations confirmed a darker nucleus surface than previously believed, aligning with earlier size estimates. For over a million years, the comet has been moving toward the Sun, originating from the Oort cloud, a region thought to house billions of comets. The inner edge of this diffuse cloud is estimated to be 2,000 to 5,000 times farther away from Earth than the Sun. Its outer border may extend at least a fourth of the way to the Alpha Centauri system, the nearest stars to our Sun. The comets of the Oort cloud didn't originate so far from the Sun. Instead, they were flung out billions of years ago by gravitational interactions with the massive outer planets during the early formation of their orbits. Occasionally, passing stars disturbed the orbits of these distant comets, sending them toward the Sun. In its 3-million-year-long elliptical orbit, comet Bernardinelli-Bernstein travels as far from the Sun as half a light-year. Currently, the comet is plunging roughly perpendicular to the plane of our solar system, less than 2 billion miles from the Sun. Temperatures are just about -348 degrees Fahrenheit at that distance. The dusty coma is the result of carbon monoxide sublimating off the surface at such a temperature. Comet Bernardinelli-Bernstein offers crucial information about the Oort cloud's total mass and the size distribution of its comets. The mass of the Oort cloud has been estimated to be as much as 20 times that of the Earth. The Oort cloud, first proposed by Dutch astronomer Jan Oort in 1950, continues to be a theory since the countless comets that make it up are too weak and far away to be directly observed. Ironically, this implies that the biggest structure in the solar system is practically undetectable. According to estimates, it might take up to 30,000 years for NASA's 2 Voyager probes to traverse the Oort cloud and another 300 years to reach its inner region. Infalling comets that can be traced back to this breeding habitat provide circumstantial proof. The cloud must be spherical in shape because of the many ways these comets approach the Sun. These comets are long-preserved, deep-freeze samples of the early solar system's composition. Theoretical simulations of the genesis and evolution of the solar system support the existence of the Oort cloud. The more observational data that can be acquired through multi-wavelength and deep sky surveys, the better astronomers can comprehend the Oort cloud's role in the development of the solar system. Some have referred to this discovery as a megacomet since it may go down in history as the largest comet ever discovered. Its estimated width ranges from 60 to 230 kilometers. To put its size in perspective, Long Island is 118 miles long, Halley's Comet is roughly 3.5 miles wide, and a portion of the Florida Peninsula is 160 miles across. Despite its size, this comet is not a threat to Earth's inhabitants, though there is a chance it might put on a sky show as it makes its first voyage in millions of years into the inner solar system. If a space rock of this scale were on a collision path with Earth and slammed into the continent, it would result in catastrophic consequences. The asteroid that is believed to have contributed to the extinction of the dinosaurs was only 7 miles wide when it struck Mexico's Yucatan Peninsula, leaving a crater 125 miles wide. The effects and climate changes from a space rock the size of comet Bernardinelli-Bernstein striking land would be orders of magnitude worse. If it landed in the ocean rather than on land, the impact might cause a tsunami. According to estimates from NASA, there is a 0% probability of such an event occurring in 2031 when the comet will make its closest approach to the Sun. Even though comet Bernardinelli-Bernstein is already closer to the Sun than Neptune, it won't begin its lengthy return to the outer solar system until 2031, by which time it will have already passed Saturn's orbit. The enormous comet will remain far from Earth, requiring a telescope to observe it in the sky. However, it may still astound observers in 2031 when it comes to brightness. Comets are renowned for being erratic. Given its size and the limited information available now, this comet may exceed expectations and put on a spectacular show for astronomers. Is it accurate to say that Jupiter may be our friendliest planet because comets would be more likely to strike us without it? The answer is both yes and no. Some astronomers believe one reason Earth is able to support life is that Jupiter's gravity helps shield us from some comets, particularly long-period comets originating in the farthest regions of the solar system. Most of these rapidly moving ice balls are predicted to be flung out of the solar system by Jupiter's gravity before they can approach Earth. Consequently, long-period comets only collide with Earth over extremely long intervals of millions or tens of millions of years. Without Jupiter, such comets would strike our planet far more frequently. Scientists have recently observed evidence of comets colliding with Jupiter. In 1994, comet Shoemaker-Levy 9 was observed impacting Jupiter. Additionally, in 2009, scientists noticed a black gash on Jupiter's side, likely caused by a comet. However, Jupiter both favors and precludes life on Earth. An asteroid belt composed of thousands of tiny flying pieces of debris exists in our solar system because Jupiter's strong gravity prevents these space rocks from condensing into a planet. Asteroids are still affected by Jupiter's gravity today, but some are now being pushed toward the Sun and risk colliding with Earth. Another intriguing tale dates back hundreds of years. A comet rarely approaches Earth within 1 astronomical unit, the Earth's sun distance of 92 million miles or about 150 million kilometers. However, a comet named Lexel whizzed by Earth in 1770 at a distance of just a million miles. 3 years earlier, the comet had streaked into view from the edge of the solar system. As it approached Jupiter, its orbit was altered, sending it directly toward Earth. The comet made 2 orbits of the Sun before once again coming close to Jupiter in 1779, which flung it back into space. Jupiter seems to have shot at us but missed. So, is Jupiter Earth's protector? The answer is occasionally. As a result, we must start making the necessary preparations to safeguard both our planet and ourselves from these threats. NASA has been working diligently on several initiatives. The Double Asteroid Redirection Test, DART, is one such project. According to NASA, DART's Didymos Reconnaissance and Asteroid Camera for Optical (DRACO) navigation imaging apparatus is located beneath the spacecraft's panels. DART represents an intriguing fusion of new technologies, with some demonstrated on a spacecraft for the first time. Since humans don't want to face extinction like the dinosaurs, NASA is organizing a mission to investigate ways to divert an asteroid. After spending a year in transit, the DART spacecraft, about the size of a car and weighing 1/3 of a ton, will collide with Dimorphos, a stadium-sized asteroid orbiting the larger Didymos. If all goes well, Didymos' orbit around Dimorphos will be altered by a few minutes spread over approximately 12 hours. The energy of DART's collision with Dimorphos will be roughly equivalent to 3 tons of TNT detonating, sending thousands of fragments into space. According to an MIT study, the outcome would be akin to a golf cart colliding with a football stadium at 15,000 miles per hour. While the asteroid's spin will not change immediately, it will gradually wobble over several days. Dimorphos may spin in several ways, including around its axis like a rotisserie. Anyone observing Dimorphos from its surface would see the previously stationary satellite swaying wildly, revealing its dark side. As a practice run for averting Earth's destruction by an asteroid, this is groundbreaking. However, research into the complex processes, from chaotic spin states to the impact of sunlight and heat propagation, is necessary to fully understand the results.